Okay, so this is either the test or the pre-test for Chapter 7 in the book, Ionic Formulas. Let's run through some of these problems together. How many valence electrons are in an atom of phosphorus? Okay, so recall that as you go across the periodic table, you have the periodic table and it starts over here. This first column is one valence electron. The second one, you have to skip over the transition metals. Then you have these other columns over here. There's like 6 of them. 1, 2, 3, 4, 5, 6. And then here's 3 valences, 4, 5, 6, 7, and 8 for the noble gases. Okay, so phosphorus is found right about here in the group of 5 valence electrons. So the answer is 5 valence electrons. So what does calcium do to obey the octet? Remember, calcium has 2 valence electrons in its outer shell. It needs to lose both of these valence electrons. And when it does, now it becomes a positive ion, positive 2 ion for calcium. So the answer is it gives up electrons. It gives up 2 electrons to be specific. What is the formula of the ion formed when potassium achieves a noble gas configuration? All right, so potassium, remember, is K, that's phosphorus, P. And recall it has only 1 valence electron, according to the scheme I just showed you on the periodic table. It's going to want to lose that 1 electron. As a result, it becomes potassium 1 plus ion. So the answer is A. What's the correct formula for sodium nitride? So if you write out the ions, sodium is +1, nitride is 3 minus. So you will note here that to make this formula work, I'm going to need 3 of these positive 1 ions, because each is positive 1 versus 1 negative 3. So the ratio is going to be 3 sodiums to 1 nitrogen. So if you look through my possibilities, here I have 3 sodiums to 1 nitrogen. So that's the correct answer is A. What is the formula of aluminum oxide? Okay, using the same rationale as above, let's go ahead and make a little box. Positive side on the left, negative on the right. Aluminum is 3 plus. And oxide, of course, as you can look this up, is 2 minus. So here, these have to add up to 0. So in the final analysis, we're going to need 2 positive 3 ions versus 3 negative 2 ions. So this is going to be 2 aluminums and 3 oxygens. The answer is B here. What is the formula for potassium sulfide? Okay, here's another one of these problems. So let's work this out in our mind. It's going to be potassium is, again, K, positive 1. Sulfide is just S, 2 minus. So I'm going to need 2 potassiums, 1 plus, adding up to the negative 2. So these all add up to 0. It's going to be 2 potassiums to 1 sulfide, which turns out to be this answer right here, 2 to 1. The 1 is not shown there. Okay, the above picture right here is a neutral atom showing valence electrons only. I'm looking at 6 valence electrons. So that would be the family in the periodic table with 6 valence electrons. Starts out with oxygen, then it goes to sulfur, and then to selenium, and so on down the row. So it has to be one of these answers, and of course there is oxygen right there. What's the correct name for the formula formed when these 2 ions combine? So there's no Roman numeral needed for calcium, that it is only 2 plus, so you just name it calcium chloride, not chlorine, okay? Calcium chloride. The answer is D. Now here you do need a Roman numeral for copper because copper also comes in the +1 form. So we're going to need a Roman numeral, but not at the end of the problem. We need a Roman numeral. We need a Roman numeral. Here's a Roman numeral, but that is the wrong name for hydroxide. So it turns out this ion is called copper Roman numeral 2, and this is hydroxide. The answer is copper Roman numeral 2 hydroxide. What is the correct formula for the compound form when these two ions are combined? So here we need a Roman numeral here, but actually they're asking for the formula, so let's just go for the formula. And this is a positive 2 and this is a negative 1. So as you can see, I'm going to need 2 negative 1 ions to 1 positive 2. So there's the answer right there. Set part 2 for ionic formulas right here. And I need to look at these ions and try to come up with the correct name and formula. So this is the potassium positive 1 ion. Sulfide is negative 2 ion. So since this is a positive 1, negative 2, I'm going to need 2 of these ions for every one of those. Okay, so now taking away all of the marks I don't need, the final answer is potassium sulfide, like that. The name, of course, is potassium sulfide. Okay, next problem. I've got the ions magnesium and cyanide. Cyanide is the polyatomic ion, OH, 1 minus, polyatomic. It has oxygen and hydrogen in it. That's one ion. And of course, magnesium is always and forever a 2 plus ion. So just balancing the ionic charges, I'm going to need 2 hydroxides for every 1 magnesium. So then you have to ask the question, do I need a parentheses? But I do here because I have a polyatomic ion and I have 2 of them. So in the end, I'm going to need a parentheses there. All right, so cleaning up all of the stuff I don't want in my final answer, which will actually reduce my grade, I'm going to go ahead and put the parentheses here and the 2, and that's the final answer. The name being magnesium hydroxide. So like that, I don't put parentheses around anything in the name, just name the ions exactly like they are. Okay, next one, number 3, ammonium and sulfate. Now ammonium is not aluminum. Ammonium you cannot find on the periodic table because it is a polyatomic ion. It has 4 hydrogens and 1 nitrogen, so that's 5 atoms in this formula. So remember, if I need more than one of them, I have to use parentheses. Sulfate, I looked that up, it's a sulfur, and then a capital O for oxygen, 4. Sulfur, oxygen, and there's 4 oxygens and 1 sulfur. It's a negative 2 charge. All right, so let's bring it over here to this side for the rough draft. I know that I have an ammonium, it's 1 plus. I know that I have a sulfate, 2 minus. So when I make my total box here showing the relative ratios of ions, I'm going to need 2 positive 1 ions to 1 negative 2 ion. So in the end, I'm ready to write it out. I leave all the charges off. There's the ammonium, and here's my sulfate. And I need 2 of these to 1 of those. I'm not going to write the 1. So this polyatomic, since I have more than 1 of them, needs a parentheses. This one, this polyatomic, because I only had 1 of them, does not need a parentheses. And the name of this is just ammonium sulfate. Keep tabs on the sulfate. That's SO4. It's not sulfite or sulfide. So the name of this ion is very important to get it right. And the last one on the test, chromium 3. So chromium 3 was not found on your ion chart, but it is found in the periodic table at Cr3+, because the Roman numeral 3 is referring to the 3, the charge on the cation. That's where we get that. Okay, so then in sulfate here, capital S, capital O, subscript 4 is a 2 minus. So now we have to do some work on this. These have to add up to 0, so as it's going to turn out, we're going to need to, we'll do it two ways. We'll do the box way, which you may like a lot. So here's chromium 3 plus on this side. Here's sulfate 2 minus on this side. So if you look at it carefully, I'm going to need 2 chromiums 3 plus, but this means I need 3 sulfates 2 minus. So that's one way to look at it. So I'm going to need 2 chromiums and 3 sulfates in my subscripts. Another way to look at it too is this 3 here can go down here, and this 2 can go down here in a crisscross fashion. You see that? And that's another way to view it. So in the final question, it's going to be chromium, and I need a 2 here. Now for sulfate, I put down the SO4, don't forget the 4 there. And since I have 3 of them, I need to put a parenthesis around the sulfate like this. Again, that's a polyatomic, and I have more than one of them, so that's when I use a parenthesis. Now to name this, you just write it out like you see above. Chromium, Roman numeral 3, sulfate. And there it is. That wraps up the test. Thank you very much.